Number 7 of rotational equilibrium recitations, dealing with a bicycle pulling a wheelie. And we wanted to figure out the horizontal acceleration required to barely lift the bike's front wheel off the ground. Well, assuming that there is no rotational acceleration, so we're just kind of sitting here, this is the situation that we have. And I'm going to choose my axis of rotation to be right here about the center of mass, because we're just kind of sitting there, you know, we're not rotating at all. And so I'm going to have a torque from the normal and a torque from the friction, and those two would have to be equal. So the torque from the normal would have to equal the torque from the frictional force. And so this would be the normal times the perpendicular distance away it is, which is x, and that's going to be equal to the frictional force times the perpendicular distance away it is, which is y. Further, we know that it's in equilibrium vertically, so that means the normal is really equal to the weight of the thing here. Weight times x. Also, this thing is accelerating forward. It's not equilibrium horizontally. So this frictional force is really going to be equal to the net force, or ma. Where the weight is really going to be the mass times gravity. The masses cancel. I can figure out the acceleration. The acceleration will be equal to g times the ratio of x over y. So that's the acceleration needed. The second part of this says to minimize the acceleration necessary to probability of what should happen to x and y. Well, if I want the minimum acceleration to get this, wheel to go off the ground, what I really want to do is I want to minimize my x here, make that as small as possible, and I want to maximize that that y component, so that that friction acts with a much longer lever arm. So I need less friction, I need less acceleration. So I guess we basically need a really tall bicycle, so we have a center of gravity really up high, and the person is basically over that back wheel.